Okay, before I get into enumerated types and the wrapper classes, what are the last two sections in chapter 3? Like I said, I did want to introduce you on how to actually use time and like the calendar. Now, Java has actually created some new classes that you can use. It's called local date, local time, local date time. There's 3 of them. I've used them here and there, but I don't really know a lot about them. So I'm going to have to kind of just look it up as I try to explain it to you. But the older way of actually getting the time is using the calendar class, which is still relevant because if you need to use, I think there's still opportunities or instances where you're going to have to use the calendar class and the date class. A lot of the methods on the date class have been what they call deprecated, meaning they don't want you to use them anymore. And then there's also the SimpleDateFormat class, which is a way to format the time on how you want it. Okay, so there is no slides on this for some reason. I don't know why these classes aren't actually in chapter 3. I kind of think it's important to introduce you to dates and time a little early, and the book fails to do that. But I'm going to just do a quick example, and this one example will actually show you how to use the calendar class, the date class, and the SimpleDateFormat. This is my notes from, I guess I'll save it. I should have named it something else. All right, let's see. So I'm going to come over here. I'm going to save this one. I'm going to call this one calendar demo.java. This is going to be a Java source file. Okay, so the name of this class will be public class calendar demo, open close, and then my header public static void main string array arguments open close. Okay, so before I jump into this, since I have no point of reference, I'm going to go to the API. I'm going to type Java API SimpleDateFormat. I'll just type calendar for now. Okay, if you click on the calendar class, it works kind of like the number format class, where if you want an instance of a calendar object, you're actually going to have to call a static method. If you scroll down to the constructors, well, there is no, it's a nested class. If you go down to the methods, okay, here's the constructor summary. So there's a constructor, but it's protected, meaning you can't actually call that through, inside of your Java file. You have to call it within, it has to be called within a sibling of the, or not a sibling, but a child of the calendar class, or from the calendar class itself. So the way that we get an instance of the calendar object is by calling the method getInstance somewhere down here. Let me see. So I'm just going to search getInstance. Okay. It's all right here. There's different methods you can call. You can get instance. You can get instance with a locale or a time zone, but it's going to grab the date and time on the computer on which this method is invoked. So this is how we get our instance. There's a bunch of methods here that you can, get the current year or whatever time you need from the actual calendar. There's a bunch here, right? I know it's a lot. I'm not going to require you to know all these methods, but the one that we're going to use is called getTime. It's going to return a date object. Okay, it's going to be the time that's on the calendar currently, which is going to be the time on the computer that I'm running this on. So let me just demonstrate that really quick. I'm going to hop over here. Now the calendar class is in the java.util package, so I need to import it like the scanner class or the random class. So I'm going to say import java.util.calendar. Okay, and then what I'm going to do, if I want to get an instance of the calendar object or calendar class, I'm going to just say calendar cal is equal to calendar.getInstance. Open close parentheses, and that's it. Right now, if you go and look at the Java API, there's other things that I can pass into this thing to kind of get a particular, or to have the instance be set to particular values, but I'm just gonna leave it like that. And because I'm curious to see what the current state of this is, I'm just gonna do a system.out.println, and I'm just gonna print out my calendar to the console, and we'll just look at what values are returned. Okay, so I'm going to compile and run this. I'm gonna go to command prompt. I'm gonna change directory to Dropbox, public, MVC. Okay, and I'm gonna go ahead and compile calendar demo. It doesn't compile. Cannot find symbol calendar. Import java.util.calendar. What the heck? No, it's still, hold on. Something must be wrong. What the heck? Import java.util.calendar, calendar demo, calendar dot get instance. Yes.
I think you spelled calendar wrong either in import or when you invoked it.
Oh, you're right. That's the problem. Dang, I didn't even see that. It's the difference between an E and an A at the end of calendar. So I imported calendar with an E at the end, and its calendar is spelled with an A at the end. So, I'm sorry, what's that? I did, yes. I don't know if you see, but I always do Control S like all the time. Like it's habit. Like wherever I'm at, I'm just typing Control S, even when I'm on a web page. For some reason, it's just become habit for me. All right, so come over here. I'm going to compile, and it still doesn't compile. What the heck? Public class calendar demo. Okay. So same problem. I put calendar with the E in my file, but I put calendar with the A on my class. I'm gonna have to change it to an E. I'm gonna save this. All right. Sorry for not knowing how to spell calendar. Okay. Now it compiles, and then to run, I'm gonna say Java and then calendar demo. Press enter. Now it spews out all this information. So a lot of times when people write classes, they write it to where whenever you print out the object to a console or concatenate it to a string, it prints out a lot of information to kind of give you the current state of the object. You can kind of read through all this, but it's basically telling you it's an instance of the Gregorian calendar, and it's giving you the current time in milliseconds. So the time in milliseconds is the number of milliseconds that's passed since the epoch date. Does anybody know what the epoch date is? Epoch date with the O. So it's like January 1st, 1970, right, is where 0 milliseconds starts for a lot of programming languages when they're doing time. So that's how many milliseconds have passed since January 1st, 1970. Okay. It's actually giving you these values for the hour of the day. It's saying 19, which is, if you know military time, that's 7 o'clock. The minute of the day is 19. Minute of the day is 19. So it's saying 7:19 when we ran this. Right now it's currently 7:20. So a minute has passed. It's giving you the number of seconds. It's a lot of information here, right? This doesn't really do much for us. But if you want to actually get what we call a date object from this, what we can do is we can create a variable to hold a date. And I'm just going to say date now is equal to, and then my calendar object, and then get time. Now, the only reason I know that get time returns a date object is because I've read or not all of this, but I've read most of this. So I know that get time returns back a date object. Okay. So when I ask for get time, I'm saving what I get from the actual calendar into a variable that holds a date. Now I'm going to have to come up here and import java.util.date. Okay. So now what I'm going to do is, instead of printing out my calendar, I'm going to just print out the date object to kind of see what information is attached to that object. So I'm going to save that. I'm going to clear my screen. I'm going to compile, and I'm going to run. And there you go, right? There's like a timestamp of the current date, right? It's telling me it's Monday, September 23rd. 19 is the hour, and it's telling me it's 22 minutes, 7 seconds, Central Daylight Time, and then the year is 2019. All right, any questions on that so far? Okay, so I basically just pulled off a date from that calendar object. Now, if you want, you can actually like come to the calendar and like set the year and the month. So you kind of have to, the way I think about a calendar object is a calendar on a wall, right? It can give you any date, but you have to actually set it by going to that year, going to that month, going to that day. And then once you set it to those values, then you can ask the calendar for that date, okay? Since I created this instance, I did not actually set the value to anything. I just asked it for the current time or the time on it, right? And it's set to like whatever the current time is on your computer. Okay, if I wanted like my birth date, I would have to like set the month, the day, and the year, and then I can ask for the time, and it'll give me my my birth date. Okay, now if we wanted to say we wanted a different format than what was printed out, right? There really isn't much options available to you through the actual date object. So what we're going to do is there's this class that was created to actually format date objects, and that's the SimpleDateFormat class. I'm gonna have to create an instance of this class. So I'm gonna come up here and I'm gonna say, okay, well, I'm gonna have a SimpleDateFormat object. I'm gonna just call it SDF, and I'm gonna use a constructor to get it, right? So SimpleDateFormat. And then I have to pass in a string of the format that I want. Okay, so for now I'm gonna put month slash day slash year. Okay, and we'll go look at the SimpleDateFormat class to kind of get a better idea of how to actually format our dates. Now this class works just like the decimal format and the number format. All you need to do is just say, okay, well, I'll take my SimpleDateFormat object and invoke the method format, and then I'll pass in my date object, which is date now. Now when I come over to compile and run this, you'll see that's the format that I specified, right? 9/23/2019. Now the only reason I know how to create this string for the format that I want is because I went to Java API and then SimpleDateFormat. Taking a long time. Maybe the internet is slow. Okay, and I'm gonna click on this, and it kind of, you can read this table in the very beginning of the class description, and it tells you like what characters that you can use to generate like what exactly that you're looking for. But if you want like military time, you use a capital H for hours, or if you just want the time like from 1 to 12, you use the lowercase h, right? The lowercase m for the minute of the hour, and then for seconds, if you want seconds, you use the lowercase s, and then capital S for the milliseconds, for the milliseconds. You can do the time zone. You can also do if it's AM or PM with the A marker. So what I'm going to do is like add, like kind of format this a little nicer. So I'm going to come over here and say, you know what, I do want to know the hour. So I'm going to say HH, and then the minute they said was MM, and then for seconds, what is SS. And let's say we want to know like if it's AM or PM. They said to use an A, and it's just say if I want to know the time zone. The time zone was, I think it was Z. Let me look back at it really quick. Time zone and lowercase z will give you that. Okay. Uppercase Z will give you. Okay, so I want to do lowercase z. Now, depending on what I use, you can kind of read this more. Like it tells you if you have repeating characters, it's going to give you the time zone like this or that. But like if I wanted Central Standard Time to be like completely spelled out, then I'll just use 1Z. But if I wanted the abbreviation, I would use 3 Z's. Okay, so I'm going to go ahead and save this. and I'm going to compile and run, and I got central. I thought I was supposed to spell that out. What the heck? Maybe I have to use more.
Capital Z.
I think capital Z was like the hour from GMT. Let me try that. Capital Z.
You're right.
Right, that's how many hours we are away from GMT or UTC time. So let me put 4 Z's in here. I don't know. Let's get crazy. We'll see what happens. What if my computer doesn't break? Okay, it's 4 Z's. Okay, now it's spelled out Central Daylight Time. All right, any questions on that? I mean, it's pretty simple stuff. So what I'm going to ask you about this on your test is I want you to know what packages these classes are from. I'm not going to require you to know it, but I think it's important to be introduced to it because using time is something that we do quite often. Now, like I said, there is a new classes that you can use. I use them a few times. I mean, I don't really do a lot of printing time out in my programs that I currently create, but let's just look up one really quick. LocalDateTime Java. See if they have an example. Oracle has some spiel about it right here. This is the actual class. I'm just gonna see if I can figure out how to use this really quick without, see, local date time. It's in java.lang, no, java.time. So there is a package called java.time, and then I have to put local date time if I want to use it. And how do I get an instance of this? Get our now. Okay. It's a static method now. Okay. Since it's static, that just means I call it through the class name. That means I don't need an instance of it. This seems pretty easy, actually. Okay, and how do I format this? Let me just do Control F really quick and look for format. Oh, there you go. Format with a date time formatter. Dang it, I don't know what a date time formatter is. All right, I'm just going down this rabbit hole right now. So date time formatter. All right, I'll just Google it really quick and I'll figure it out. All right, so what I'm gonna do is I'm hop back over here. So they basically just tell me from everything I just read, they said use java.time.local date time. Okay, and then it's a static method, meaning it's just like the math class. So the second date I'm gonna print out is I'm just gonna say like local date time, and I'm just gonna say local date time dot now. That's what I saw in the API. So I'm just gonna run this and see what happens. I should get something back. Okay, and there's my local date time. It's in this format. I do want to format it just like the date above. So from everything I read, you just call format, and then you have to pass in a date formatter. Let me look at that one more time. So, wait, where was I? Format, date formatter. I click this, and how do I just do something really simple? There's some constants in here. Okay. All right. Oh, this is a. Okay, I could use this. I'm gonna use this right here. I'm just gonna copy this. I'm sorry, I don't have all this stuff memorized yet. At some point, I will. Java time format. That's the name of the package. Java time format. Okay. So if I want to use the date formatter class, I have to import Java time format date time formatter. Right, that's the package it's under. So I'm just come over here really quick and import Java. Was it? Dang, I already forgot what it was. Anybody remember Java time? Oh, Java time format, and then got date. Was the date time? format. All right, I import that, and then if I want to format this, then from what I read, all I have to do is just pass in that. Yeah, I mean, that's what I read. Let me just copy this right here. Or actually, we'll just keep the string the way it is right there. And I'm going to save that. Compile. It compiles, that's always a good sign, right? I just added a bunch of stuff I don't know nothing about. And there you go. There's my year, there's my month, and my day. Right? I could probably just slap this in right here and get the same. Let's just take this time like that and get the same result. Now, the reason why they created these classes is because dealing with the date, it became, I guess when it was initially, from what I've read, it's been a while since I researched why they did this, but it's the format or the local date time, local date, and local time classes are all thread safe, right? I guess like whenever you create programs where there's multiple processes running at the same time, you'll probably do that further down the line. But these classes are designed to be thread safe. So it's just like an improvement to what was previously existing. But anyways, I just added this format right here, and I'm going to just print this out, and we'll just see what it looks like. I mean, it doesn't look like any different than what was previously done for the simple date format. Just some classes are a little different. I'm going to save that, come over here, compile, and run, and I was able to format that local date time object. It was pretty straightforward. It's just like a new class of doing this. So this is kind of like the way that I learned how to do dates and times, but it looks like this is like the newer approach that has come out with the most recent version of Java. Any questions on that? All right, so let me go ahead and hop back to the lecture. The next two sections are really pretty short, but they can be a little confusing. So I'm just going to read through all the slides, and then I'll do the example. And then we get to the wrapper class. I'll read through all the slides, and then I'll do the example. All right, enumerated types. Java allows you to define an enumerated type, which can be then used to declare variables. An enumerated type declaration lists all the possible values for a variable of that type. The values are identifiers of your own choosing. The following declaration creates an enumerated type called season. So they created an enumeration for season, and they said winter, spring, summer, fall. Once the type is defined, a variable of that type can be declared. So they're basically creating a variable to hold that enumerated type. And to get the value of that enumerated type, they're just, through the name of the enumeration, they're doing the name of the enumeration dot and then the value that they want. These values are referenced through the name of the type. Enumerated types are type safe. You cannot assign any value other than those listed. Internally, each value of an enumerated type is stored as an integer called its ordinal value. The first value in an enumeration type is an ordinal value of 0. The second value is 1, and so on, just like the way characters are in strings. However, you cannot assign an numeric value to a enumerated type, even if it corresponds to a valid ordinal value. So even though they have this ordinal value, you can't create a enumerated type and assign it a 0 or a 1. It has to be a valid type that you created. The declaration of an enumeration type is a special type of class, and each variable of that type is an object. Okay, we'll talk more about classes and objects in chapter 4, but they're basically saying that enumeration is essentially a class. So we're basically writing a class defines however many objects that we say are in the enumeration. The ordinal method returns the ordinal value of the object. The name method returns the name of the identifier corresponding to the object's value. And then here they give you an example, and that was it. Okay, I know that was a lot to digest. Like, it was a few slides, but it said a lot. That was a lot of stuff that was super confusing. So like everything, I'm a visual person. I like to see things actually work for me to completely understand it. So I'm going to come over here and I'm going to make a demo called Enumeration Demo. So I'm going to call this Enumeration Demo. And this is going to be a Java source file. I'm going to save this. Okay, so I'm going to say public class enumeration demo. And then public static void I don't know if you saw the syntax for this. It is something a little different, right? Something that we're not really used to doing. So basically, so just think about this problem, right? So I have, we'll just use the example they did. So I want to represent seasons, right? And there's only 4 seasons, 4 possible seasons, which is fall, spring, summer, and winter. Okay. I don't want any other values. Now we could probably, like, if we're keeping track of, what season it is based off time or whatever, we could just store that data as a string, right? Where the possible values of that string are spring, summer, winter, right, fall. But if we do that, right, a string can have many values, right? So like if I'm not controlling how this data is being stored or prompted from the user, like if I ask the user, like, what season do you want, or what season is it, and they enter in taco or something like that, right? That's not a valid season that I'm looking for. I'm only looking for, right, spring, summer, winter, fall. Okay, so they just entered in a valid value, but if I'm storing that as a string and I'm not doing any check on it, that value is being stored as whatever they entered. So enumerations are great whenever you have a specific set of possible values and you want nothing outside of those possible values, right? So one of the examples that they gave you was an enumeration for the seasons. Like another good example, I think, is like the letter grades in a class, right? A, B, C, D, and F, right? And there's no other possible value. Like those are the only things that you can get. So when we create an enumeration in Java, we're going to go outside of the main method, but within the class, and we're going to type enum, which is a Java reserved word, and then the name of the enumeration that we want to create. Now they use season, so this is a Java identifier, meaning it's something that we make up. So if you wanted to just do something like this, not that, actually take that back. Like this, that would also be a valid Java identifier, but we always do things that make sense to what we're doing. So I'm going to use season, and then I'm going to use, now I don't know why the book said winter, spring, summer, fall, and all lowercase, because an enumeration is essentially a class with constant objects. I'm like most people put them in all caps. So let's start off from the beginning. Winter is the first season, right? First season of the year. Then we have spring. Then we have summer. And then fall. Okay, so I just created my enumeration. So I have 4 possible values. Now, if I wanted to create a data type of the season enumeration, I just say season, right? So I'm specifying the data type, and then my favorite season, and I'm gonna set that equal to my favorite season. And I'm actually a fall person. I like fall because I live in San Antonio, and summer and spring are just normally too hot. I guess spring is all right, but sometimes you have those really cold days in the very beginning. But I don't know, fall always seems like the best time to like go walking or camping or doing anything in San Antonio, right? So I'm gonna say my favorite season is fall. So that's what I do right there. And then if I wanted to print the value out, I'll just say my favorite and then I'll just say my favorite season, which is right here. And let's just see what we get. We go ahead and save this. Oh shoot. Okay, I'm gonna hop over to command prompt, clear the screen, and I'm gonna compile it compiled, right? We just did a bunch of weird stuff, but it compiled. And I'm gonna run this class. Okay, and my favorite season is fall. That's in all caps, and it's in all caps because it's a constant. We gave it the name fall. Now, there's no way currently that we know of, right, from what we learned in Java 1, how to make a name that is nicer looking when we display it. But in Java 2, you can actually add to this enumeration to have like a nice display name or have other values associated with each one of these objects, right? So winter, spring, fall can have like a display name where it's fall like with a capital F and lowercase ALL. Some other things that you can invoke through this enumeration is because it's an object, you can say, you can get the ordinal, and then you can also get the name, which is essentially what was printed out right there. I don't know why. Well, I mean, I guess because this is calling the toString method. Anyways, we'll come over here and compile and run, and there you go. The ordinal gave me 3 because it's the third item in the fourth item in the enumeration. So it has a value of 3 where winter has a value of 0. Another really cool thing you can do with this enumeration is if you wanted to know all the possible values, and we'll talk about for statements or for loops in chapter 5 and arrays or containers in chapter 8. Actually, I think we're talking about chapter 5 as well. Talk about this in chapter 5, but you can just run a for loop and you can just say, okay, well, give me all the seasons. And I have to like run this a couple of times because I forgot what I need to call exactly to do this. I'll say season S inside of season dot, I think it's values. I can't remember. It has this method that it's going to give you like all the values inside of the enumeration. If you just kind of wanted to iterate through it, and then you can just do system.out.println, and you can say, well, I guess we could just do S, right? All right, let me just save that and compile. I got it right. It is values. Sweet. And then run. And that's what I printed out inside of that loop. So basically just iterated through that collection and printed out every value. But anyways, those are the 4 possible values that I can have for a season. Now, one of the things that you should probably also know is it's standard practice to like not actually have your enumeration inside of another class. You should have your own file for your enumeration, but we're not going to talk too much about enumerations in Java 1. We just wanted to introduce you to them. In Java 2, we're going to actually like add a bunch of extra data to these enumerations. But if you come back over to where I compiled, let me just clear my screen really quick, and I type the command DRI, you can see that there's this weird .class file that was generated right there, right? It's Enumeration Demo $season. And the reason why that was generated was because I essentially created bytecode for another class. So having the enumeration inside of my own class basically created a separate bytecode for that particular enumeration. So there's actually 2 files that got generated when I went to compile. I had the enumeration demo, which was my main class, and then I had enumeration demo.season, which was the class inside of my enumeration demo class. Okay, so just note that in the future, typically enumerations go inside their own file. Like if I wanted to create another enumeration, I'm going to make an enumeration or a class file just for grades. Let me come over here, say new file, save as. I'm going to call this one letter grade. And I'm going to save this as a Java source file. Hit save. Now this is where we're going to get kind of funky because we're not going to follow like the public class because this is not a class. It's actually public. Well, do I need to make a class for this? Dang it, I'm so confused right now. No, I can't remember. I'll have to mess with this really quick. It's just public enum and then the name of the enumeration. And then inside of the enumeration, you just specify the values that you want. and I want an A, I want a B, I want a C, D, D, and F. Right, I don't put a semicolon there. I believe that's all I do. It kind of matches what I did here, but the way I did it here is I just put it all on one line. Now I don't need a semicolon because I'm just defining this into its own file. I'm going to save that enumeration. I'm going to assume that it's working. If it doesn't, I'll go back and fix it. Now if I wanted to create a variable to hold a letter grade, now I'm going to have to do something a little crazy. I'm going to say letter grade, and actually, yeah, letter grade, and then I'll say my grade, and then my grade will be equal to letter grade dot A, right? So I'm saying I have an A in this class, and over here I'll just say my grade is, and then I'll say my grade. I'll just print it out. Now give me the value. All right, let me just save this and make sure this actually compiles. Let me clear my screen. Compile enumeration demo. It did compile. That's always an excellent sign. And run this class. Okay, and you can see that my grade is an A. Okay, so what's actually happening here is I defined the enumeration for the letter grade in a different file. Now, because both files are in the same location, I didn't have to like import or anything like that. Java already knew, okay, well, this letter grade actually exists in the same location as the enumeration demo. So it actually knew what the letter grade is. It didn't tell me like, cannot find symbol letter grade, right? So I have this file that has what a letter grade is, and then I have this file is where I actually used the letter grade. Any questions on that? All right. Okay, so let me just hop to the next section. So that is enumerated types. Pretty interesting. They're actually pretty powerful. They're actually used a lot as well. But in Java 2, you'll talk more about them, and you can actually do like add more parameters to each one of those objects. All right, wrapper classes. I'm just gonna read through it. It's just gonna be a lot of information coming at you, but every primitive data type has its own wrapper class, and I'm just gonna read through this really quick, and then I'll do an example on some of this. So the java.lang package contains wrapper classes that correspond to each primitive data type. So you have the byte, the short, the int, the long, the float, the double, char, and boolean. And the names of the wrapper classes are basically pretty much the same thing, except they start with a capital, and the integer is actually spelled out, and character is actually spelled out. The following declaration creates an integer object that represents an integer 40 as an object. So here they use the wrapper class integer age is equal to new integer 40. Okay. An object of the wrapper class can be used in any situation where primitive values will not suffice. For example, some objects serve as containers for other objects. Primitive values could not be stored in such containers, but wrapper class objects could be. Okay, so basically these classes were created to provide helper methods and also allow you to create your primitive data as an object. Now you might say, why the heck would I want to create primitive data as an object? But from what we read on the slide, which might not be very clear, there are some classes that are containers, like the list class, that don't accept primitive data. Okay, so in those classes, your data has to be an object. So you can, what they call wrap your primitive data into an object, right? Basically store it into the integer, into an integer object, and then you can put that data into a container. And there's other situations where you might want to represent your primitive data as an object. Wrapper classes also contain static methods that help manage the associated type. For example, the integer class contains a method to convert an integer stored in a string to an int value. So you can call integer.parseInt and then convert this string into an integer, and then you can store it into an actual number that you can use to do problems with. They often contain useful constants as well. For example, the integer class contains min value and max value, which hold the smallest and largest values of integers. AutoBoxing. AutoBoxing is an automatic conversion of a primitive data type to the corresponding wrapper object. So you can create a variable that's an object reference variable to an integer, and then you can essentially just assign it an integer, and it's going to hold that value, right? So here they create the object reference variable, then they declare a primitive data type num set equal to 42, and then they store what was in num, right? And they take that value and assign the object reference variable to that value. The assignment creates the appropriate integer object. The reverse conversion is called unboxing. So you can take an object of the integer type and store it into primitive data. It also occurs automatically as needed. Okay, so basically, if it could go both ways, they're saying, are the following assignments valid? Explain. So you're saying a double value is equal to a double literal. That is valid because you can go either way. And then a char wrapper class object is equal to, well, basically use the constructor to create a char, and then you assign that value to a primitive char object or char variable, and both are okay. So above you have the double literal is auto-boxed into the double object, and below you have a char object that is unboxed before the assignment. Okay, so it's either way. I know this might be confusing, and this is why I don't like to test you guys on this kind of stuff, is because I kind of just, I mean, it's important to know, but like right now we really don't know enough about classes and objects to actually make anything useful out of this. Now, the most useful thing I think is being able to convert a string into an integer or a double or whatever it is you want to do. Some other cool things that you can call on some of these wrapper classes is the min and max value. So let me just do a quick example of this. So I'm gonna hop over here. I'm gonna make a new file. I'm gonna save this as, I'll call this one a wrapper class demo. All right, so save it as a Java source file. All right, I'm gonna just do public class, and then public static void main string array arguments. All right, and let's see. I really don't know what to show you about auto-boxing, and they already did all that for you. You can look at it if you want. But I think probably the most important thing is to say I have a string, and this is called like my fave number, and I'll just say that my favorite number is 5. Okay. Now I want to convert that into a integer so that I can say something like this. Just say like I asked the user what the favorite number is, and they entered in the value, but I read that value in as a string, and I'll say my favorite number. Oh shit. Shoot, sorry, I was on, dang it. I'm recording myself. I don't know if YouTube likes people cussing. All right, I'll say my favorite number plus 7, okay? So I have my favorite number and my favorite number. And let's just say, I'm gonna say, okay, I'm gonna take, for some reason I'm under the impression that this is an actual integer, and I just say my favorite number plus 7, and I'm thinking I'm gonna get back 5 plus 7, which is 12, but I can actually gonna get back 57 because it's a string and you're concatenating. So I'm gonna hop over here, clear my screen, compile. Yeah, compile. Okay, and then run it. And there's my favorite number, which is 5, and then my favorite number plus 7 is 57, right? Because my number, for some reason, is stored as a string. But to say, for some reason, like this data came in as a string, I want to convert it to an integer. So I can say int num, and I can say num is equal to integer. And then there's a method called parse int. If you can look at the Java API, there's a lot of useful methods on a lot of these wrapper classes. And then here you just pass in a string, and the string that I'm going to pass in is my favorite number. Now I'm going to take the same, we'll do the exact same thing, but I'm going to just print out the numeric number instead of the string value for it. Okay, so I'm do the same thing on top and bottom to show the difference between the two. So now when I save this and compile and run, you can see that I actually get the right results at the bottom because I took that string and I converted it to an integer with the method parseInt. If you go to the API, just go to Java API 8 and then just type integer, click here, and then you can kind of read about all the cool things that you can do with this. And there's like all these cool methods that you can invoke. You know, one of them actually pretty useful, I think, is you can convert, you can like call, where is it? I forgot the name of it. You get like the hex value of a number or the binary value. Oh, here you go. It's a static method, so you invoke it. Anything that says static in front of it means that you don't need an instance of that object to invoke the method. You just invoke it through the class name, like the way we did for the math methods. So I can invoke two binary string. So just say we wanted to know like what my favorite number is, but as a binary, as a binary string, or as in binary. So what I can do is say my favorite number in binary is, and then I can just call the static method integer dot to binary string. Was it to binary string or to binary str? To binary string, and then you pass in an int. Okay, and I'm going to go ahead and just print out the hex value as well. And I'll say to hex string, or was it hexadecimal string? Hex string. All right, save that, compile, run, and then here is a binary representation of my number 5. Right, that makes sense because there's only 2 digits, right? So 0, 0, 1 is 1, 10 is 3, 11 is 4. Wait, I'm off by 1. What the heck? So 0, 0, 1 is 1, 10 is 2, 11 is 3, 100 is 4, and 101 would be 5. Right? And then like the hexadecimal for 5, it's pretty simple, right? Because it goes to 16. It's still 5 because you don't use an A or any of the letters to represent that. So like the hex value for 15 it would be an F, right? So if I just change this to 15 up here and compile and run, you can see that the hex value for 15 is F. So I mean, there's some cool methods that you can invoke, like if you're trying to make some program that's going to give you the binary value for some input that you take in, or the hex value for some input that you take in, you can do that here. Some of the other things that they gave you that were pretty cool, I thought, were if you wanted to know like the minimum value for an integer, I'll just say like min value of an int, and then you can just say integer, and then there's an actual constant that you could call, which is min value. I believe that's what it was. Let me look back to the lecture really quick. So right here, min value and max value. Okay. You can call min value, and if you want to know the max value, so I'm expecting to get negative 2 billion and positive 2 billion. But to test that this actually works, because I don't really know what those values are. I know it's in 2 billion, but let's call this for a byte. We know what that is. So byte has similar methods and constants. So I'll just say like byte there and byte there. Okay, so I'm calling the same constants for integer and byte. I need to change this to max save that, come over here, compile, and run. Okay, so here's my min value for an integer. There's my max value for an integer. There's my min value for a byte and my max value for a byte, right? So there's a lot of useful methods that you can use on these things. So like, I mean, it's always interesting to learn more than what is actually required you to know for Java 1. It makes you a better programmer. Like if you're interested, just go to Java API and look through the methods. Like some of them might be difficult to understand, but like things like 2 binary value or 2 binary string, I think, to me, that might be pretty interesting for something that you're trying to do for like another class or something. I don't know, but there's a lot of cool things that you can do with a lot of the wrapper classes. But AutoBoxing and unboxing are another thing that you can do. We really don't have a real use for that yet. Whenever we talk about list and containers, then we can put our primitive data into an object so that we can put it into a container that can hold it. Any questions? Okay, so that's all I have. Next class, we'll hop into chapter 4.